All right, everybody. It is time for ITMS implementation best practices and review. Now, of course, we're presenting this as ITMS level, so we're going to include things like monitor solution and other things. It is quite a large presentation, but we've got it down to a point where it takes the high-level pieces of architecture as well as best practices and just gives them in a kind of a document that just shows you the things you need to know to get through. I've also added a section to demystify the package servers and how unconstrained, constrained, how task servers are set up and so on. It's been a mystery for over 15 years. It's a very easy concept once you understand the difference between the two, but you find yourself when you're implementing new site servers and so on, it's like, at this remote site, do I need an unconstrained to start and a constrained? We still have confusion after all these years. So I've written up something or a couple of slides to show you the easy way of remembering it and what the benefits are in different configurations. All right, so you may have seen some of this stuff. We have ITMS fundamentals up on the eLibrary, but this has been updated for 8.5 to change any of the numbers, all the recommended settings and so on. All right, so we're going to get right into the notification server and SQL implementation and design. Now remember too, when it comes to implementation, it also applies to troubleshooting. So don't look at this as, well, I've already put my stuff in, what do I need to know this for? It also guides you in understanding where some of your problems are. So if I say, you shouldn't have more than 35,000 agents on a notification server, right? That applies to troubleshooting too, because if you've exceeded that, obviously, you're finding the problem. All right, so these are just some common issues we see out there, whether we're in support, education, sales, PM. The very common things that we see are things like incorrectly matched architecture for the implementation. So I'm not saying you didn't assess it, you didn't design it right, but the fact is, you would think that you would know that a 100,000 node would have a hierarchy. Well, we see designs out there that are running on a single NS, and they're wondering why the console's slow, why things are not working. Insufficient configuration for the architecture is basically saying I use the out-of-the-box settings for my 35,000 node implementation. Well, you know what's going to happen. The defaults are set for 1 minute for requests and so on. It's going to be a very busy architecture. The rollout didn't match the design, so you did all the work to get this thing architected on a big Visio diagram and all that, but you didn't match it to the actual physical needs. Okay? So another one is excessive non-data or non-essential data movement due to incorrect use case analysis. This is just a fancy way for saying that you've got a lot of stuff happening on your network when it's really not necessary. Do you need that software inventory every 5 minutes? No, you don't. So you might have certain things set incorrectly in your design. Site configuration deficiencies. So basically, you're using a bunch of Windows 10 computers as your site server for a site with 2,000 agents on it. That's probably not a good thing. I/O and resource deficiencies. So you have this great SQL server. It's got 4 gigs of RAM on it, but it's got SSD drives, right? So there's I/O contention. You're not getting fast SQL or responsive consoles. As well as your ongoing alignment with your business. So it is all about the business too, because what you're doing is you're meeting business objectives with an IT tool. So not accounting for growth, things like you're expanding your company 1,000 endpoints a year, but you're not planning for the architecture, not properly setting up security. So everybody has access to the console and they're moving things around and they're deleting computers and so on, as well as adhering to things like compliance and regulation. Okay, so these are very common things. So we're just going to start with some of the specifications. Now, I have been doing the updates for this for probably about 10 years, and there's slight changes here and there. So in this case here, your server specification is directly proportional to the amount of endpoints that you have. Okay, we can put up to 35,000 on a single notification server. Okay, and this is managed agents, and the rule of thumb is real simple. More cores, more RAM, faster I/O. SQL off box allows you to support a lot more agents. Okay, so the example in this illustration is just saying, if you have hard drives, you have a spanned hard drive storage array, it might be 15,000 with slower, SAS, or not even SAS, going way back there, SATA and so on. You can increase it to 25,000 with SSD, possibly 35,000 comfortably with, I/O cards and things like that. So some of these are obvious, but we forget about them, right? We just do our day-to-day jobs, go and administer the ITMS, but we forget that it grew, 5,000 nodes, and we forget the numbers. All right, so another obvious one is the number of solutions you use increases or decreases the number that you can support on a notification server. In this example, 45,000 easily, just putting the S&P on. I don't know why you would. S&P and inventory might be about 40,000, and the full ITMS supports, or our supportability statement is 35,000 per notification server that's properly designed. Okay, so it's also important where the SQL Server is installed. Now, if you have some, liquid nitrogen cooled NS with 75 processors, you can probably get SQL and everything else on there. But the rule of thumb is if you're greater than 5,000 managed endpoints, you probably want to have your SQL Server off box, right? Okay, so on box, it's up to 5,000, off box up to 35,000 for SQL. Okay, another one we often forget is an optimized configuration. So really get to know all of the tasks that are happening, the scheduled items, any of your frequency of inventory, whether it's also doing even right down to how often it polls for tasks. There are many, many settings, and you'll find a lot of these guidances in the Planning for Implementation guide on our support websites that'll show you certain things. What is the update configuration interval? If you have it set for 1 minute, it's going to be really busy. If you have it set for 4 hours, it's not going to be as busy. Okay, so spreading any of the tasks that happen on a regular basis is also a really good thing to do to reduce the impact on that notification server. Okay, site servers, this is one of the biggest things. The more site servers you have, and dispersing all of that load helps the load on the notification server. So a single notification server, if you have a site server on it, you should be using that site server to talk to the other site servers to help with the load. Okay, so we highly recommend using the site infrastructure. All right, we're not going to go through every single detail here. They are mentioned in the Planning for Implementation guide on the support site. So what I want to get across here is the difference between on-box and off-box. And if you look at the different levels going from 100 all the way up to 35,000, you'll obviously see that the resource requirements increase. That's pretty obvious. But also there's other things that need to be taken into consideration, right? First of all, is it going to be off or on box? Well, we know the rule, 5,000 or greater off box. Okay, so you'll see that we need less resources for the off box versus the SQL on box. We also notice that as you increase in the number of endpoints to be supported, you have a splitting of the drives, right? So the resources are a little more, but the fact is we're splitting it out for optimization, right? Put your operating system on one, put your files and things that you share, your packages and so on another, and any other things like applications and things like that on another drive. Okay. Let's see here. All right. So none of these specifications have actually changed in the current 8.5 as far as the number of IOPS and so on and so forth. It is important to note that you must at least meet or exceed the IOP recommendations for each of these levels, and that's where we can assure you that you'll get good performance on your machines. All right, so as you probably know, Microsoft SQL is the heartbeat of ITMS. It's the most important thing. It's where you should put the most money, the effort, the design, everything into. Okay, so first thing you're going to ask yourself is whether you're troubleshooting or you're designing this, is the SQL Server database sized properly? So if you're doing an initial config, let's say you're doing an off-box migration, always know that it takes at least 8 megabytes per endpoint to start a new database, right? So if you have 1,000, it's 8,000, etc. And always add at least 10%. So this is for the initial database configuration. So in our example here, 5,000 endpoint, 8 megs per agent on the initial load. is 40 gigabytes plus 10%. You would start off with a 44 gigabyte. Now, we obviously, we recommend that you don't use percentage, have a fixed expansion for your SQL in the settings. Okay, it seems to work a lot better. The performance is really good when it has to, expand the database. Okay, so after you initially create it, always account and always be thinking about things like fragmentation, right? So make sure you have a maintenance plan in place for Microsoft SQL if you can, or your own created scripts to maintain them. Okay, and also account for the number of solutions. So the 8 megabytes that I quote here is basically you got inventory, you've got software going, you've got all the plugins installed, right? And depending on what you have enabled, if you're just an inventory shop, this number would be greatly reduced, right, for the initial load. As well as things like policies and tasks. So if I have an inventory schedule that's going every hour or something like that, and there are constant changes, I have to account for that kind of stuff too. Okay, so how is it implemented? All right, so are we using traditional legacy drives, or are we using things like SSD or Fusion IO cards, things like that? Always separate the different components if you're over a certain amount, at least 5,000 endpoints. There's a benefit even at 100, right? So even if you have 100 endpoints, splitting out the drives, it's just different channels, right? So you get more performance. Okay, so if you're using traditional, this is our recommendation. It hasn't changed over the years. Actually, we used to recommend RAID 5, but now we're saying RAID 10 for the database and transaction logs, RAID 0+1 for the temp DB. Okay, and obviously too, if you're dealing with things like SAN connected storage and things like that, sure, you can probably get the IOPS and so on, but make sure that it's dedicated for these pieces, right? And you're not sharing it with the Great Plains database and the medical database, and it's impacting the resources. All right, so SQL Server, this is obviously off box here. Okay, so if you meet or exceed these, we pretty much assure you that you're going to have good performance on your notification server. And as you increase in the number of nodes, so does the splitting and the splitting of the resources like storage and so on. Okay, so what we're recommending here is as you go further down the numbers, you're going to be splitting out things into the operating system and the SQL application. That could be on C drive, database on D, transaction on E, etc. Right? The more you split it, the faster it goes. Now, obviously, we tell you to look at Microsoft's best practices for setting up SQL Server. There's a lot of articles out there on doing multiple transaction log files, multiple database files versus one solid file. So always take the guidance of the manufacturer. Okay, and we're just showing here that, of course, the IOPS increase as well as the storage increases as you go up in the sizes of the endpoints. All right. So that's just our SQL and notification server recommendations. Okay, again, most of this is in the planning and implementation guide. So let's take a look at site server implementation. All right, there's a couple of obvious statements again, right? The hardware will be proportional to the number of endpoints it services. So we can support up to 7,500 and in some cases 10,000 because you've seen a setting there that says so. We recommend up to 7,500 agents for any single notification server with the right hardware, right? So this is not a Windows XP box sitting in a corner somewhere with a single hard drive and 2 gigs of RAM. Okay, so each notification server can have up to 600 site servers connected to it, but it's not a hard and fast rule. We're just saying if you had a fully loaded site server with a task package, everything just going, and you had 600 of them, your notification server can handle that. But this does not say that if you are, let's say, an oil company that sells gas, right? Let's say it's Costco. They have 400,000 stations across America. Well, you might have that many site servers, but there's only one PC at every place, right? So this number can be adjusted. Okay, so you basically have to look at the size of each site, as well as the amount of site servers that go to the notification server. Okay, so that's just our hard and fast. We recommend 600 and no greater unless you have certain conditions. All right, so we're just saying consider existing hardware. Site servers can be anything, right? They can have a desktop OS on them. If it's only servicing maybe 4 or 5 clients, well, just pick up the one that's sitting in the reception area, right? And reusing stuff is really good for the environment and all that fun stuff. Not going to get preachy, but it's a good way to reuse equipment. Okay, so the number of solutions obviously will impact the performance as well as the size of the storage, obviously, right? If you're using deployment solution, it might have 20 gigs worth of images. If you're using software updates or patch management, that could have 10 gigabytes of patches that are constantly being, superseded and cleaned up. Okay, so depending on what you use will determine how much storage you need on each of the site servers. We can also look at configuration of the site server, whether you tell it to retain packages over time, whether you tell it to delete if they're unused. So there's a lot of things we can do, but typically look at the solutions that are installed, calculate how much storage space they need for all their files, and you should get a rough number of what you need on the sites. Okay, this one is often forgotten. Even to this day, we've had hierarchy for, since 2007 or something or other. You must have a site server for each leg of the hierarchy, okay? So its main purpose, of course, is to transfer packages, events, all sorts of stuff between them, right? So replication for package distribution, it's absolutely necessary. Okay, and yes, I know about the registry hack that you can just turn off and so on and so forth. That one is not recommended, especially in bigger organizations. All right, so let's look at some of the specifications of a site server. So again, the same rule applies. As you have a certain number of endpoints, it will increase over the numbers. And our only recommendation is when you're servicing a large site. You're getting around 3,000 to 5,000. You would probably want to split the operating system and the storage itself, right? Okay, that's just pretty common sense stuff, basically looking at the separate chains or channels, allowing the file sharing to be more efficient. Okay, and you'll notice between 10 and 100, that's a desktop OS, so let's just say it's a Windows 8 1 box or Windows 10 box. One of the constraints, of course, is to understand that there's a maximum connection count for desktop OSs. So what was it, Windows 7 was 10 or 20. I think XP was 10. Windows 10, I'm not too sure. I think it's 20 maximum concurrent connections. Yeah. So anytime you get over those numbers, or if you want to use the desktop OS, do realize that if you have 100 people on the site and you're serving, let's say, a Microsoft update, it's only going to connect 20 at a time, right? And it'll deny the others. Okay. So Server OS, of course, is unlimited. It's basically anybody who connects to it can use it. We recommend that for the larger sites. And storage is also determined by the number of applications, the images, the packages, etc. All right. Okay, so this is just a quick slide to tell you what a package server is. I'm sure most of you know what it is, but they're basically deployment mechanisms. So they transfer packages. You can have a task server that does tasks. It'll take in agentless inventory for monitor solution. It can act as your Pixie or iPixie server. So it has multiple uses, and again, we know why, or what it does, and that is reduce the load on the notification server. So we don't always need server class hardware, as I just showed you. Okay, and it's good for the network, right? It prevents the extraneous amount of information going between all the endpoints and at different points. All right, so whether you're designing or troubleshooting, it's always good to know your network topology. So you should have known this way before you started designing, knowing where the points are, where the fast sites are, the connections between all the sites, and so on. Okay, so definitely know that before you start rolling them out. And we have a few recommendations. So we want to make sure that in a case of a package server, we want to make sure that you put the agent on the location you want the files to be on. So this is a very common thing that happens. We just blast an agent out there, and then we allocate it as a site server or a package server in this case, and it's on C. C drive's only 40 gigs. All of a sudden, you put 80 gigs of stuff on it. Well, we know what the agent does. The agent fills up the C drive, then goes to the D drive, then goes to the E drive. So make sure you plan that up front, because you'll start seeing package servers drop because there's no storage available, right? Okay, so what you can do in this case, if you already did it and you're worried about it, you want to get it over to E, you can reinstall or uninstall and reinstall the agent. It'll have the same GUID, everything will be in the database, but it'll be on the right drive you want it on. Okay, so how to do it? Here's a huge command line for you. Just focus on the red area, the drive. It's the drive switch, so -D. Tell it to go to E, program files, Alteris, or wherever you want to put it. Okay. All right, another one is if you're just starting out, stagger your deployment of package servers. So the easy way to put that is don't just allocate 50 different computers around your organization as package servers, because they're all going to want to do the same thing at the same time. So if there's 250 gigs of images and so on, you're going to have 50 site servers pulling the packages and communicating at the same time. Okay, another one is stagger the deployment of the packages. So if you do have to deploy package servers, do a couple at a time. Do a staggered type of install, right? All right, so another one is obviously use package servers with multicast enable. This also applies to peer-to-peer, because you do have that peer-to-peer ability between the notification server and a package server, as well as the agents, right? Now, you can't do both, right? It's either multicast or peer-to-peer when it comes to packages. Okay, so this section is going to show you the different use cases for unconstrained and constrained, and the reasons why or why not to use them. And as long as you know this stuff up front, you won't make the mistake of having an orphaned site that no longer receives packages if something goes down. All right, so in the first scenario, we have an unconstrained configuration. So this is what we call this unconstrained. So what we have is two sites, let's say, and we have the notification server site. So what we have to make sure is that wherever your notification server is, its site, right, its defined site, must also be part of B and C, or just B, or whatever your combination is. So without that, they don't have that intercommunication, and they won't efficiently, in some cases, they won't even deliver packages. So first thing, set up your subnet to talk to B, C, and A. Right? So what you're going to do is place two site servers or a site server on each of the sites set to unconstrained. Okay, so what does this do? This gives us WAN bandwidth savings by simply getting the packages down to the package servers. Okay, so the notification server communicates to site server 1 and 2. It delivers the packages, and you have two connections to the two sites. Okay, so it's excellent local file service. So the clients will receive them just from their site servers. So this is a basic configuration. Okay, so the best thing about that is they pull from the package servers. There's two connections instead of, let's say, if you look at the endpoint, 6 and the two site servers. So it's 2 versus 8. Okay, multiple unconstrained. So this is a case where you have a large site, let's say, with double site servers on there. Same thing applies for each of your sites. Make sure the notification server site is a member of that. And you would put multiple unconstrained servers on there, right? So at this point, what we're dealing with is 4 connections from the notification server down. So yes, it is impacting it a little bit more. Okay, so now we have 4 connections versus 4 plus the 6 agents you see on the bottom here. Okay, so it's good load balancing. Right? They're both pulling their packages from the notification server, and your agents will go either to site server 1 or 2, right? And you know how that works. It'll determine who's the fastest, you know, who's available, who has less clients. You can pretty much set that up. But your agents talk to the 2 unconstrained site servers. All right, so fault tolerance in this case, if either one of them at the site goes down, the site still works. Everything's fine. That one site server is just going to be a little busier, right? Okay, so this is good fault tolerance here. And again, we're also saving by saying 4 connections to the notification server versus all the agents and themselves. All right, so let's look at a hybrid configuration. So again, make sure your notification server site is part of your other sites. And this time we do an unconstrained and a constrained site server at each of the sites. Okay, so we have 2 connections down, and the unconstrained site server talks to its constrained one. So it gets a package, it just automatically goes over to the constrained site server, right? So you still only have 2 connections on the WAN, or on the LAN there. Okay, and how does it work for the agents? The agents pull from either one of the site servers. Okay, so it's very similar to the constrained. All right, so here's the problem though. If any one of the unconstrained servers goes down, everything goes down, right? So you won't get any new updates, you won't get any files delivered, right? Because that's kind of the one site server that feeds the entire site, right? Okay, so that's an obvious one. The benefit was that you only had 2 connections to it, but the benefit is no good if the unconstrained goes down, your site is not getting its files. All right. Any questions on package servers? Did that help a little bit? The different configurations? Okay. All right, so task communications are obviously different than package servers, so we're now talking about task servers. Okay. We know that the server starts the task communications. You basically set this up, go into the site management, and make one of these a task server. Okay, and these are all the things that a task server does, right? Or can help with execution and so on. So multiple tasks can be run, provides all the logic behind the tasks themselves, right? Delivers command line and quick delivery items. Out of the box power management, so that's done through the tickle process and the power management DLLs and so on. Okay. All right, so obviously we recommend 1 task server per notification server at a minimum, right? Regardless of size, you have to have a task server outside of your notification server because you don't want everybody going to the notification server to get its tasks. Okay, so it does impact it if you don't have an outside of a task server outside of a notification server. All right, so its goal is to reduce traffic to the notification server and the task services. So on each of the sites, you would set it up very similar. Make sure that the notification server is on the sites A or B, simply so that they can talk to each other. Okay. Our recommendation for the notification server is that site that the notification server sits on must, basically, if you can define it as a Class C subnet, that limits the number of serviceable managed agents to 254 endpoints. So it kind of guarantees that no more than 254 endpoints would ever utilize it. So imagine if all your task servers were down, the maximum it's going to get hit is 254, right? Okay, so you would create sites for each of your site servers. Again, we know it supports up to 7,500 clients if you have the right hardware. Okay, and it can be server, desktop OS. It doesn't have a lot of resource requirements. Okay, so you can assign multiple task servers to each site if you need to. Okay, they're not managed like task server or like package servers, unconstrained, constrained. It has nothing to do with that. It's more balancing the load of the tasks that are happening in your environment. Okay, so the way we load balance instead of unconstrained, constrained is through these settings here. So we can basically say, how do you want the site server to react? I could say, choose a task server relative to the remaining capacity of each. So basically, whichever one has the least connections, use, right? Choose which one has the agent that has the fastest connection. So that's another load balancing way of doing it. Say, go to the fastest one, as well as the fewest computers concurrently set. Okay, so we can do any one of those 3, and also you can clone these policies to take groups of site servers to react differently. Let's say the ones in Hong Kong you might want to be based on capacity, whereas the ones in America might be the number of concurrent connections. Okay, so in bigger environments, there's some recommendations on the task update interval. So a general rule of thumb, and hopefully this is working in practice, is when you go into the task agent settings, increase them to at least 30 minutes in larger environments, right? So right now, I don't know what they're set for. It's probably 5 minutes or something like that. And in the task service settings, these are ones for the task servers themselves, increase it at least to 5 minutes. Okay, so if your number of task servers is exceeding, let's say, 100 of them, you should really consider increasing these numbers. But do know that when you do a quick delivery, you set it for 30 minutes, there's a good chance that it's going to be 30 minutes to get it, 30 minutes to do it, right? To do the task. Okay. All right, so here's some guidance for task services implementation. So we recommend that you include multiple subnets within the notification server subnet. So we're basically saying you can have all the sites you want, but make sure the notification server site is part of it, right? There's nothing wrong with that. Okay, make sure that bandwidth is good in this situation. Also, do place task servers closer to your remote clients. So again, if you have 5 sites all around the world, make sure there's a task server at each one to help out with the load. Okay. But here's what you don't do. Don't put a task server in every location with a package server. So basically what they're saying is don't have 100 islands out there that don't talk to, let's say, the notification server site. This is something that we did way in the past, around 7.6. You could set up the site management out of the box to just be everybody doing everything, right? If you didn't define your sites, basically all package servers would be listed in your code bases. It's not very efficient, and most likely your NS would service almost everybody for the tasks. So it loaded it up a little, because we also don't have a requirement to have a task server and a package server everywhere you use deployment solution now. That was a requirement back in 7.6. Okay. All right, take a quick look at network boot services. Okay, so we know what this is about. This is basically the Pixie boot services to allow you to stage, deploy, capture images, do jobs and configuration tasks. Okay, so typically the Pixie protocol is controlled on a network, so it's usually the network ops people are going to either ban it on certain subnets and so on and so forth. So you do have to know your topology before you start implementing it to make sure that that protocol will traverse some of the subnets and so on and so forth. If you're in a staging area, it's pretty easy. You put a server there, a network boot server there, and just do all the staging on the one subnet. Okay, so if you're doing deployment across the organization, you might put a network boot service server in each of your sites that you actually do deployments or re-images and so on and so forth. Okay, now also remember too that it does host files, boot images especially, right? So it acts kind of like a package server. When you make a change to the Pixie boot configuration, it will basically update itself to all the network boot servers. Okay, so they work a little bit closer to a package server. All right, so inside of them, you got Pixie services, boot images, NSCAP, or the PS shares, as well as the driver database. So if you have a really big hardware independent image that has massive amounts of drivers to represent every computer in your organization, you have to account for that too. Make sure that you have the space. Okay. So again, as I mentioned, when you add drivers, you change the boot image, it will also transfer to all the other network boot servers from the main. All right, so implementing. So any subnet that you do an action on, whether it's capture or deploy an image, it must have access to an NBS server, right? So a network boot server. So, however, we notice in most organizations, they may block certain things like Pixie traffic and so on, or access to the Pixie server. Okay, so there's ways around it. These have been around for years and years. You know, I'm sure network people in here would understand this far better than I do. But we can use DHCP force mode, which is basically going on your DHCP server, whether it's a Windows one, Microsoft DHCP, and actually setting the options to basically say, if you need Pixie, go over here and it will allow you access. IP helpers, obviously, to go through different subnets that might be banned. There's other things like port fast enabled and other switch things that we can do. Now, the resolution around that is basically put an MBS server anywhere you need this stuff, like in the local sites themselves. Okay. All right, so monitor services. I don't know how many people use monitor solution, right? Okay, so these are some basic guidelines to implement these, right? So we know that they're used for agentless monitoring, right? So it's kind of like a repeater. It takes in all the information from the network devices as opposed to the notification server receiving it. Okay, so that helps with the impact on the notification server. Okay, it's on the notification server by default. It just gets installed when monitor solution gets on there. Okay, reduces the load on the notification server by offsetting all of the demand. It's also integrated with the site server infrastructure. So if you put the monitor plugin and you make it a monitor server, it will act as what we call a remote monitor server, or RMS. Okay, so it's very important to note the operating systems that you're using for the monitor services. Right, so this is what we support for them. Okay. So we don't need any special configuration to have these services work with one or more site servers. And we always say, put it on a secure computer. Make sure that this monitor service is on something that's properly locked down, that's properly, the permissions are set and logins and so on, because it can be sensitive data, right? We're transmitting, let's say, full configurations of a router through the LAN. So there is a little bit of data that does go on this agent too, so make sure that access is restricted. Okay, so what do you need for it? You must have a semantic management agent. You must have the PPA plugin, or the pluggable protocol architecture. And you also have to have the credential manager set up with the proper credentials for anything that you're going to do agentless. All right, so that just sets up some of the services. Okay, we're going to continue, Andy? Okay. All right, so now we'll look at the ITMS components that are part of the implementation. Okay, so this one here, this slightly changes every year. This, again, is found in the Planning and Implementation Guide if you need to reference it. All right, so we know now that a notification server can handle up to 35,000 with the proper hardware specifications. It's up to 600 site servers per notification server. We recommend no more than 300 network boot servers per notification server. It's more effective to change your network instead of putting 300 boot servers out there, right? Okay, up to 7,500 clients per site server. That's our recommendation. That doesn't mean you can't set it for 10,000. The option is still there, but make sure it's a really powerful computer. Okay, the amount of concurrent Pixie sessions per boot server or network boot server is up to 200. So basically you just sent out 200 images to 200 computers. That's what we're recommending as the max for that. Now console sessions, little debate on this. It's really easy to remember how to increase this. It's up to 100 console sessions, right? So that's 75 management at any time. That's just basic console access, or up to 25 asset accesses at the same time. And this is all about the amount of memory that's used. So if I use my browser and I connect to my notification server on my desktop, I'm taking 50 megabytes, and that's an estimate, right, of RAM off the notification server. Multiply that by 100, that's the kind of RAM you need. So if you have, for some reason, a 64 gig notification server and all it's got is the NS on it, you could far exceed this number easily, as long as you have the memory. Right? And that could be tracked simply by looking at the task manager and seeing it go up or down. Okay, Internet Gateway, as Rob mentioned yesterday, after RU1, so the improvements in the Internet Gateway configuration. Right now, it's 30,000 connections it's up to 30,000 agents registered to a single Internet Gateway, or it really translates to 3,000 concurrent, right? And we know what the limitation is now. Rob was mentioning Apache has a maximum of about 3,000 connections. In the RU1, we're looking at 15 to 20,000 because they're using, what is it, .NET Core to do the Internet Gateway. So these are all rules of thumb on this. Okay, so this one here should be obvious to you now. Our maximum supported is a 1 by 6 by 35,000 hierarchy, 210,000 endpoints for total. Obviously, some in this room have far exceeded that with help with support and other methods. But yes, you can exceed this depending on hardware and all the things I discussed, as well as your configuration. Okay, so the simple operation here is all the agents talk to their child servers, the child servers talk to the parent server. Okay, and the number one rule is never install asset management or any of the CMDB components on your child notification servers. It's meant to be at the top, and it will not work. And it'll flip your status all the time. It'll go active, retired, active, retired. You don't want to see that. All right, so another recommendation is don't use hierarchy unless you have to, right? So if you're thinking hierarchy is a great idea, if you want to have a notification server at every site in the world, but it only supports 100 managed endpoints, you're better off having a single notification server in a faster location that will handle your 35,000, right? It's always going to work better if you don't split it out. You split it as if you have necessity to do so, right? Oh, and the other thing with that is obviously you can use organizational views and groups to separate a lot of the tasks and scoping and so on and so forth. Okay, so we'll take a quick look at topologies. These are the obvious breakpoints. So this is for up to 5,000. It's single notification server with a single site server. Internet gateway if required. It's a very basic configuration, right? This is what should handle it, and SQL is on box too, right? In this case here, I don't think we're going to recommend SQL Express or any of the free versions, okay? But if you're doing testing or you're in a dev environment, for sure, use any SQL you can. Okay, 15,000. We're looking again at a single notification server with an off-box SQL because we exceeded the 5,000. Single site server that services the data center and maybe the local corporate office, and then remote site servers that are fed from that site server. Okay, so this will handle at least up to 15,000 endpoints. Now, obviously, the more site servers you add, the better things work. It's more efficient, load balancing. And one internet gateway, even though we recommend a minimum of 2 for load balancing. 35,000, yep, it's kind of simple math, right? So you got a single notification server, SQL Server off box, higher power of course, not using SQL Express. A data center site server that services all the rest, and this is your choice to make them constrained or unconstrained. And then 5 at the remote sites, right? Now this is a perfect world scenario, but it's not really like this everywhere else. You have different numbers of sites and locations and connectivity and so on. And then this is the monster, right? This is your 175,000 endpoints. You're looking at 5 child notification servers, 1 global, or what's the new word now? We just call them parent notification servers, right? Yeah. Acting as the global notification server, you will have a bunch of site servers. So in this case, everything's located in the data center. This is how it works efficiently. Taking your notification servers and putting them all over the globe is certainly not an efficient way to get communication between all of them. It'll take hours, let's say, to take a package from one to the other, or tasks, or any hierarchy items. So we must have 1 site server per notification server, which is indicated as the green ones here, and a multitude of regional site servers to service the 175,000 endpoints. Okay, you also have SQL off-box or a massive cluster, whatever you have that's really efficient, right? Our recommendation is off-box for each of them, and a really sufficient one for the top parent, as well as internet gateways for each of the notification servers to service the remote connections. Okay. So we'll just take a look at some of the scenarios. This one really incorporates all of the different scenarios you might see out there. Okay, so this is a corporate notification server implementation that has multitude of connections, different speeds, different policies like decentralized or not. Okay, large sites, small sites. But I won't confuse you with this big diagram. We'll zoom in a little. So in this case here, we're looking at a notification server that's servicing a bunch of relatively small sites. So they're under 100. It's a super fast, high-speed connection to the notification server. So at this point, there's no necessity for site servers and so on, right? Okay, small locations, small populations, fast network. In this case, we're looking at a bunch of small sites, right? The 10 sites with under 50, but the problem is the low-speed connection. Right? They're all really, really slow speed. So the site servers are implemented to obviously allow faster distribution. It only has to download once to the site and they share it from there. And again, we can infer that turning on P2P, multicasting, and other things could also help in this case. All right, then we look at a situation where you have larger populated sites that have a high-speed connection. It's the population that then determines a site server on that site, right? We're talking 1,000 endpoints, if anything. So you would put a site server on each one of these smaller sites just for efficiency in the local network. Okay, and another implementation is, let's say in this case, the scenario is probably that it has to be managed separately because they can't have the policies at the parent, whether it's compliance or adhering to other policies. But it's also a large site. So we're looking at a notification server that's connected through hierarchy. So this would be the child notification server of this site. Okay, and it also has to serve. It also has to service other sites that are connected to it. So we can look at this as one IT regional management group, right? So we have a nice high-speed connection, and that's the big thing. You have to have a high-speed connection for the hierarchy. So in this case, we do. And we have a combination of everything I've talked about so far. Large sites with a slow connection, small sites with a fast connection. So here it's just basically showing that even though it's got its own notification server, you want to offload the load on it by having site servers at the separately managed site, as well as down on the on the higher populated ones with the low speed. Right? So everything really applies. It's just separated out into its own child network. And the last one is decentralized. So yes, we have a major notification server implementation, but for whatever reason, you can't have any of the data going over to the parent. Right? It's totally decentralized. It's in one place. So in this case, it's pretty obvious. You would have a notification server that manages this 15,000 endpoint implementation with site services to offset the load. Okay. So if you have a remote location and you want to actually and it's only connected by internet, it could be Verizon, it could be any type of non-corporate internet, you can set a site server down there, add package services and so on. Make sure that cloud-enabled management is enabled on the agent itself, and listing it in the proper place in site management, which is the default internet site, it will allow it to be shared outside of the local network. So you can use it as another point. But it's fully internet connected, so yeah, you can definitely do that just by turning on the agent cloud-enabled feature. Yeah, and it acts just like a regular package server. So the code bases that come from it are the determination of whether that's accessible or not is the same as if it's inside the network. So yes, they're referred to as internet site servers. Yep. Any other questions? Yep.
Recommended. Do you have a recommended topology if you were trying to use the AWS offering?
Oh, I am not the right person. Hey, recommended topology for AWS implementation. We have a question about that. Weren't you the big guy?
Oh, hello.
I do on-prem.
No, it's okay. So recommended topology, there's really not, like anything we do with ITMS, there's no real one size fits all. Different customers have different requirements, different needs from a security perspective. The one thing that I will always recommend is, obviously use CEM for that, and the reasons why is, do you want to protect your database, right? Your CMDB, just put it behind, the kind of firewalling, so to speak, right? And use the cloud-enabled management gateways for that from a security perspective. Another recommendation from a topology perspective is if you're going to have ITMS and AWS, you can run it in multiple scenarios, right? You can have it to where you run everything cloud-enabled management, whether it's a remote workforce or even your on-prem installation, where everything is SIEM, or you can have the connector for AWS, where you have the on-site kind of a private VPN, like a tunneling type of VPN between AWS and your on-prem stuff, and you can have basically site servers at your on-prem installation connecting over to AWS. So again, there's multiple ways of doing this from a recommended perspective. Whatever you do, from a recommendation, it's security, keeps security at the top of the list, right? So
Absolutely.
back to you.
All right. Right here. Thanks, Bob.
Related to the previous, with the settings for task server, with the WebSockets, does that change with the times and everything?
I personally don't know. I don't think Rob's here. When it comes to WebSockets, when you're at the recommendations for task servers, does WebSockets change that in any way?
No.
Yeah, sorry.
So right now, the current guidance doesn't change. From that perspective, task server continue to do what it does from a WebSockets perspective, which is TCM. It'll work, basically through the traditional method, so to speak. You'll continue to have your packet server, your task server. Think of TCM, which is your persistent connection, as just a communications mechanism, a faster way of telling a client, wake up and go do something. So it's merely a transport type protocol, right? To go do something through traditional methods. It's just that real-time connectivity to it. Does that make sense? Does that answer your question?
Well, some of the settings with task is specific to how frequent it checks in and sets that.
Yeah.
So if it's a real time and makes things faster, does that affect it with the WebSockets?
No.
Okay.
Okay. Stay right there.
For implementation of the database?
Don't yell at me.
For implementation of the database, can you make comments on sizing for monitor solution?
Oh, you got me off guard on that one. I used to have that tip of my head. And you're talking about, it depends on the configuration, right? So if you're doing real-time data, historical data, I haven't personally. Now, I think maybe Jim might know if you've ever done these assessments before. There's a certain amount of data that's retained, and that's part of the database, of course. If you say, give me everything for the next year, it's basically going to grow and grow and grow, right? If there's no purge set, right? So the answer is, it depends on how you set it, right? But I don't know if there's a hard or fast rule like I gave you with the 8 megs per client. I've never seen one. Anybody else seen any recommendations?
Traditionally, 4 to 5 megabytes per.
Traditionally, we recommend 4 to 5 megabytes per server when you're building out your architecture planning, if you're using Monitor. Keep in mind that whether or not you're reading live data in real time out of your data center environment, that's going to impact your data storage capabilities on the database side. Also, if you're tying into your virtual environment, please be aware that VMware doesn't really like it when you've got some live monitors running in their environment, because what will happen is the utilization rules that are built into VMware can sometimes get really angry because they're going to see your server taking up more power, more I/O than it should be. So just be aware of that caveat. Other than that, 5 megs.
Constant communications, agents
Correct.
constantly feeding the data.
Yeah.
Now that would of course be for your RMS servers and so on, but
Correct.
yeah, everything's going to depend on configuration. but 4 to 5 megabytes per endpoint that has the monitor solution agent on it. Okay. All right. How we doing for time, big guy?
I am not looking at the time, but who's first?
Thought he was coming to attack me.
Has there been any discussion of high availability or hot cutover? You know, if a server goes down or things like that,
Right.
or looking at containers and new technologies.
Right now, I believe, correct me if I'm wrong, if there's something new, stop me. But the current guidance that we've had, obviously, is, you know, backing up the database, and we can do things on the database side, but as far as clustering the actual web app and so on and so forth, nothing's changed in this release, as far as I know. Other than the recommendations we have on our support site that show for high availability, these are the 5 steps you should observe, which is obviously backup SQL clustering, backing up your servers, you know, standard storage.
There's actual TVs that have been published on the net as to best practices for a DR scenario and stuff.
Yeah, DR was the key.
So if you need the link, just reach out. I'll make sure you get it.
Yeah, I'm pretty sure if you put in ITMS and DR or disaster recovery, it would definitely come up with an article. Yeah. Okay.
Two things. One, just FYI for those asking monitor questions. I've used it for 10 years, thousands of servers, nearly 100% virtualized. I've noticed no impact running the agent within VMs. We do quite a bit on vCenter to monitor the infrastructure health. We monitor all sorts of things within the storage array using vCenter, using monitor solutions. So it's a good solution. We've noticed no major impact on database size. Obviously, if you're worried at the gigabyte level, then sure, you're going to be worried about database size. But in today's day and time, I would hope that you're worried about size at the terabyte level. And
Right.
if that's the case, don't worry about your database. It's
That's
fine.
a lot of historical data.
Yeah.
Do you
out of the
have
box,
purging? Have you set up your purging to in a regular
all,
cadence? Or?
all out of the box. So,
Right.
you know, purge 50,000 events out of the event log.
Interesting.
Do your roll-ups, right? 5-minute intervals for 7 days, and then hour intervals for 14 days, something
Right.
like that. So it's all out of the box, and it's been more than sufficient, and has been an integral part of becoming a 24/7 shop without a knock.
Right.
Absolutely.
Oh, thank you.
Secondly, a question around package server assignment. Can you talk about manual pre-staging versus all package servers automatically? And specifically, what I've run into is a realization that I don't know how to get the packages out to the package servers ahead of my clients. So my clients clog the pipe while my package server's throttled. They're throttled, but everybody's downloading simultaneously. So what's the point of the package server? How do I get my packages to the package server first?
Oh, that's a tough one, actually. Thanks, Jim.
Thanks for being way over there, James.
Thanks, Jim.
Sorry, Bob, you're getting your steps in today. Answer that for me.
So the easiest way to kind of handle site server issues, especially with package replication, is to take a look at the core settings of your targeted agent settings. If my site server isn't getting data more rapidly than my clients are, then that package replication process really isn't going to happen in a timely manner. So my advice to that question would be, make sure we have more aggression on how often our site servers check in. That way our clients will get the software far after. Or within the actual policy for the software, I would just schedule it out into the future. That allows all the site servers to get all the data they need. Does that make sense? Correct. Correct.
Yep.
It's all math. Exactly. Yeah.
Yeah.
Yeah. It's the client timeout setting. It's in the advanced section of your site server configuration settings.
Yeah, so
Maybe not
Don,
make 5.
I don't know, Don, if that really did answer all your questions, but one of the things that I want to address too is one of the things that Jim was bringing up too is if you have your site server targeted agent settings configuration, obviously we've run into the same scenario lately. I've been running into that same question a lot. The idea there is just to accelerate or make your target agent settings for site servers a little more aggressive than your rest of your clients would, right? So they kind of beat everybody to the punch when it comes to downloading. Now, a lot of things come into play, right? If you have peer-to-peer turned on, then you're essentially instructing the client to have that behavior, right? Is go outside of your preview of the subnet or the site to go do that. So, with that said, is a multiple, I guess, tiered approaches. One is manual assignment. So you have automatic with manual assignment for your package distribution. The idea behind that is the automatic will only download the package if and when a client actually requests it, right? That's the automatic package distribution with manual pre-staging. But if you have those locations where you absolutely must, like that package needs to be at that hub so that everybody pulls from that hub instead of coming all the way across the pipe to go get that package, then you do automatic with manual pre-staging. Make sure you click on manual pre-staging on the servers in question so those packages get automatically, basically what that word is pre-stage the package before anybody else gets it. That in combination with a more aggressive targeted agent setting. So instead of, let's say your clients are checking in every hour or 2 hours, I would say those site servers in question or all site servers, you just make them do it every 15, 30 minutes, right? So they beat everybody else to the punch. Good question. I don't know. Yeah. So now that you mentioned that, there is a thing I can't remember right now very specifically. Patch management, same thing but for patch management.
Yep.
Like Jim said, set it to the future, right? Set it to a future, but there is a setting I can't remember right now. Jim, if you have the answer, please help me out here. But
I believe it's tied to the patch update interval.
yes.
So if you look at the patch update interval and how often it's checking for that value data, it should then talk to the site server and that communication.
The site server should then allow the package to replicate out via the software library using the same common approach, right?
Yeah, that's just not what I've seen. Again, we approve all patches every cycle, and therefore 100% of the schedules are in the future. And in fact, the Gen Pop schedules are 3 weeks out. But within that first 24-hour period of download from source into my notification server, I see my package servers and my clients simultaneously downloading those packages from my notification server. And with proper throttling, it's fine. It's kind of a curiosity thing for me, because I'm just a little bit ashamed that I don't know. As long as I've used this product, I don't know how to make this happen.
So I would check a few key areas. Number one, I would check my core settings configuration, and now we make it easier with 8.5 because you can see it more easily. I would check, and when you look at the process of your approval for your patches, are you downloading and staging at the same time, or are you separating that out between hours, or what does that process look like?
Multi-select 49 bulletins say distribute. And
So you do downloading and distributing in the same thread of a
At the same
task.
time.
Yes.
Yep.
Okay, that might be a part of why you're experiencing this issue. I would try segmenting out the download process, watch and see the file matriculation happen in your server, and then validate that the pass-through is completed on the NS. Check your site servers, make sure that the replication policies match what you want to have happen, and then look at the client payload side of it.
All right, so you want to take me from a one-step to a two-step. That's
Correct.
Okay.
just
I'm
to
I'm
validate
lazy.
this specific question.
Yeah.
For your day-to-day process, it shouldn't be that way.
Okay.
Okay, thank you.
All right. Well, thank you very much, everybody.
To learn more, visit go.symantec.com/manage.